Hello everyone. In this video, I'll be talking further about system of particles and rotational motion. In this video, I shall cover vector product, angular velocity, angular acceleration, angular moment, and torque. Vector product. A vector product of two vectors A and B is a vector such that magnitude of vector z, which is the vector product of vectors a and b, is equal to the product of the magnitude of vectors a and b and the sine of the angle between the vectors a and b. The vector z is perpendicular to the plane containing the vectors a and b. So, if we take a right-handed screw with its head lying in a plane of A and B and the screw perpendicular to the plane, if we turn the head in the direction from A to B, then the tip of the screw advances in the direction of the C. This is similar to this case in which we can use the right hand rule, in which the fingers of the right hand is curled up and the fingers show the direction of the angle between A and B, and the thumb will show the direction of vector C, which is the vector product of A and B. Now, the angle theta, which is taken in this case, will be always the angle which is lesser than 180 degree. Now we can see some of the properties of vector product. First property is A cross B is equal to minus B cross A. Second is A cross B does not change sign under reflection. That is, in case of reflection, vector A will become minus vector A and vector B will become minus vector B. That is, minus A cross minus B is equal to A cross B. Now, this is the distributive property of vector product. That is, A cross B plus C is equal to A cross B plus A cross C. And A cross A is equal to 0. That is, the vector product of the same vector will be 0 since the angle between the vector is 0 and sine 0 is equal to 0. Now we can see the vector products of the unit vectors I, j and k. That is, I cross j is equal to k, j cross k is equal to I, and k cross I is equal to j. Similarly, j cross I will be equal to minus k cap, k cross j will be equal to minus I cap, and I cross k will be equal to minus j cap. Now, vector product of A and B, two vectors A cross B is equal to the determinant of I, j, k, ax, ay, az, bx, by, bz, where ax, ay, az are the components along the x, y, and z axis for vector A, and bx, by, bz are the components along x, y, z axis for the vector B. Now we can see the angular velocity of a rigid body. This is a rigid body which is rotating. And we know that in the case of rotational motion, the particles are moving in a circle. And the circle with the center fixed along the fixed axis of rotation. So we may characterize pure rotation by all parts of the body having the same angular velocity at any instant of time. That is, in the case of a rotational motion, all the particles in the body will be having the same angular velocity. Now we can see omega cross r that is equal to omega into OP from this figure. That is omega cross into OC plus OP. Omega cross OC is equal to 0 as omega is along it. Hence, omega cross R is equal to omega cross OP. And omega cross OP means it is the vector V, which is the velocity which is tangential to the circular path. So, we have derived the relation between angular velocity and linear velocity. Now, angular acceleration. Angular acceleration is the time rate of change of angular velocity. That is alpha, which is angular acceleration, is equal to d omega by dt. If the axis of rotation is fixed, the direction of omega and hence that of alpha is fixed. In this case, the vector equation will reduce to a scalar equation. Now, torque. It is the rotational analog of force and is called the moment of force. There is torque tau is equal to the vector product of R cross F, where R is the position vector OP and F is the force. Now, angular momentum. This is the rotational analog of linear momentum. It is given by L is equal to R cross P. The time rate of change of angular momentum of a particle is equal to the torque acting on it. That is tau is equal to dl by dt. This is also analogous to the case in the case of linear momentum, where force is similarly equal to the rate of change of linear momentum. That is the second law of motion. Now, conservation of angular momentum. dl by dt is equal to tau exterior. Similarly, similar to the case where the linear momentum, differential of linear momentum, that is the rate of change of linear momentum, is equal to f ex. We can prove a same analog equation, which is dl by dt is equal to tau ex. Since this is the analog in the case of rotational motion. That is, when tau ext is equal to 0, dl by dt is equal to 0, or L is a constant, since the differential of a constant is always 0. Hence, the angular momentum will be constant. This is the law of conservation of angular momentum. So, this is the end of this video. This video I have just gone through a few important concepts related to rotational motion of rigid bodies. If you have got any doubt in any of the concepts mentioned in this video, please comment in the section below this video. Thank you.